Okay, so in this section, we're going to take a look at trigonometric integrals, right? And we'll start off by looking at integrals involving powers of sine and cosine. All right, so for example here, the integral of cosine cubed of x. Right now, at first approach, I'd like to maybe do a u sub, right? But the only problem with that is that, well, if I do a u to be cosine x, I don't really have the factor of sine of x for my du, right? So what's going to come important in these integrals that involve powers of sine and cosine is the relationship that exists between the cosine and the sine. Right, so I know that the Pythagorean identity tells me this, and also all the variations of this, right? I can also have, right, cosine squared x equals to 1 minus sine squared x. Sine squared x is equal to 1 minus cosine squared x. So I can really use these interchangeably, right? And I'm going to do that to help me solve here, right? So the fact that it's cubed, it's odd, is going to tell me that I need to kind of split it up, right? Because if you notice here, the Pythagorean identity, that is an even power. So I'm going to rewrite cosine cubed as cosine x times cosine squared of x dx. All right, and now we can see here, now I can apply the Pythagorean identity here, right? Cosine squared is equivalent to 1 minus sine squared x, right? These are equivalent expressions. I can interchange them, right? That's what that equality is telling me. It's equal. Okay. All right, so now here, all right, I can use the u sub now, right? All right, now my u is going to be cosine of x, right? How would I know that? Because I have sine squared. I can't really do anything with that, but the derivative of sine is sitting right here as cosine of x. So I know I can set up u to be sine of x. Du is cosine of x, right? Dx. So now I can plug this back in and we get 1 minus u squared du. Okay? And now that's a basic power rule integral. Now we get u minus 1/3 u cubed plus c. And then lastly, we just plug in back sub, right? Our integral was in x, not u, minus 1/3 sine cubed of x. And again, the plus c. All right. Okay. So here we say, all right, so that is how I approach this integral here. All right, now let's take a look at, what if I had a mixed sine and cosine, right? So we have sine to the 5th of x times cosine squared x dx. All right, so having just finished the above integral, you might see this and look, oh, I should just substitute in cosine squared for cosine squared x to be 1 minus sine squared x. Now the problem in doing that is, well, now your expression is strictly in terms of sine, powers of sine, right? If it was just sine of x, that'd be fine, right? That's a basic integral. But if it's powers of sine, I'd like to do a substitution, but in order for that to work, I would need the derivative to be on the outside, which I don't have. I eliminated a factor of cosine, right? I don't have any extra factors of cosine in order for me to be able to apply that type of substitution. So this is not going to be it. That's not what I want to do here. All right. Now, instead, what I'm going to do is I'm going to focus on the sine, and I'm going to break off one factor of sine. Right. So I have sine of x, and then I'll have sine to the 4th of x, which I can rewrite in this manner. Right. That's sine to the 4th. So I still have 5 factors of sine. And now we have cosine squared of x dx. Okay, and now instead what I'm going to do, now that I have that factor of sine, I'm actually going to want my substitution to be u to be the cosine of x. Because I have that, the du sitting out there, right? Du would be sine x dx, right? But now I need to change everything else to cosine. Well, that's okay, right? This here, as we saw above, sine squared of x is 1 minus cosine squared x. So we get here. Now here, be careful with all our algebra here. Sine x, 1 minus cosine squared x squared times cosine squared x dx. I want to distribute. First of all, expand this quantity here, right? So I'll expand that quantity, all the time leaving sine x alone. All right, so we get 1 minus 2 cosine squared x plus cosine to the 4th power of x cosine squared x dx. Okay, and then one last thing here. I'm going to distribute in that cosine x. Notice again, oops, have not done anything with the sine of x, just keeping it there. Right? I need that factor for my substitution. So distributing in that cosine to the 4th of x plus cosine to the 6th power of x dx. Okay. All right. And what you're going to gather here is that as the higher the powers, the more work is going to involve here, right? So now I'm ready for my substitution. I'm going to let u be cosine of x and then du to be negative sine x dx. Now there's no negative out there, so just keep in mind I need to multiply that in there. Okay, so now the integral becomes, make sure to carry that negative with you. U is cosine of x, so we get u squared minus 2u to the 4th plus u to the 6th du. Okay, and notice why it was crucial for that extra factor of sine to be there. It allows me to do the u sub so that now I have a basic power rule integral. Right, so this becomes negative u cubed over 3 minus 2u to the 5th over 5 plus u to the 7 over 7 plus c. As always, we're going to substitute back in there. I'll distribute the negative as well. Negative cosine cubed x over 3, right, minus 2 cosine to the 5th of x over 5, then minus cosine to the 7th x over 7, and as always, plus c. Okay. All right. So that's how you would approach a problem like this, right? When we have mixed signs, sine and cosine. Now, what about the case where here, like something like this, sine to the 4th of x. Now, all of our powers here, well, we have an even power of sine, right? So if I want to break off one factor, I don't have a cubic type expression, right? So I can't really break off a factor of sine, right? So I have to try a different approach. Now, in that case, I'm going to think of this as sine squared x squared dx. All right, and what I'm going to rely on here are what are called my power reducing formulas or half angle formulas. So the sine squared of x is also equal to 1/2 minus 1/2 cosine of 2x, right? This is a trig identity, right? I'll state it here without proof, okay? And also cosine squared x equals to 1/2 minus, or excuse me, plus 1/2 cosine of 2x. Okay, so those are our half angle or double angle identities, or our power reducing identities. So now I want to apply one here. Okay, so I'm going to use the sine squared one, right? Now notice how this is helpful, because now instead of having sine squared, I have a cosine, but it's to the 1st power, which again, as we notice here, that it can be challenging to integrate the powers of the sine and cosine. So the fact that I've reduced it is really helpful. All right, and now I'm going to expand this out, right? So here we're going to expand this out. So remember, FOIL this out, so we get 1/4, and then 1/4 and 1/4 is, so you get negative 1/2 cosine of 2x. All right, and the last one is plus 1/4 cosine squared of 2x dx. Now I'm almost there, right? Almost there. I still have a squared, right? But notice that's better than a 4th power. Okay? So let's do the power reducing formulas again. All right, from above. This one's fine, the 2x, right? No power. Sure, there's a 2x in there. I can deal with that later. But here we have 1/4 and 1/2 plus 1/2. Be careful here. We're doubling 2x, so it's cosine of 4x. All right, and let's kind of combine like terms. There's really only one like term here, right? It's this one, and here 1/8, right? All right, 1/8 plus 2/8 is essentially 1/4, so we get 3/8. All right, and then the rest, keep track of my coefficients here. We get 1/4 and 1/2 is 1/8 cosine of 4x. And now all of these are basic integrals, right? 3/8 is a constant, so we get 3/8x minus, now be careful here, right? Now we have a composition here. The u sub would be 2x, but again, right, for something that's so basic as here, just remember what's the derivative of 2x is 2, which I don't see out here, right? That's a half, not 2. So I have to make sure I divide it in there, right? So divide it by 1/4 sine of 2x. Same thing here, right? Derivative of 4x is 4. I don't see it out here. So divide through by 4 or multiply by 1/4. And we get sine of 4x. And as always, don't forget your plus c. Okay, so now we have a way to get to the integral of sine to the 4th power of x, right? Again, when it's just even, here we used a power reducing formula, right? Now there's a summary here in our textbook, so I'll show you. I clipped the the formula here, but let me scroll down here. So here's our strategy, right? So we're looking to integrate powers, mixed powers of sine x, cosine x. So here we focus on if k is odd, do this, right? And it gives you an approach to take, right? If j is odd, do this instead, right? Break off one of the factors so that you can use, essentially you want to be able to use the power reducing identities, right? Now, if j and k are even, right? So if you have both even powers, right, then use those power reducing formulas. All right, so that's a nice summary there. This comes from our textbook section in integrating in trigonometric integrals, which is 3.2, I believe, in our OpenStax Volume 2.